In section 7.1, we're going to start working with applying the exponent properties involving products. So we're going to work through some of the properties of exponents, the ones involving products, which of course means we're talking about multiplying. And your learning objectives for this section are to be able to use the properties of exponents that involve products. Key vocabulary here is order of magnitude, what is a power, what's an exponent, and what's a base. Okay, so when you think about a power, I'm going to go back actually. When you think about a power is something like a to the n power. The exponent here would be n, and the base would be the a. Okay, so a is the base of the power, n is the exponent, and together the two items are a power. Okay, and when you look at the product of powers property, what it essentially says is that when I multiply products that have the same base, okay, so the base has to be the same, then what I'm going to do is I'm going to add the exponents. Okay, you'll notice that the base does not change. So in this example, I see 5 to the 6th times 5 to the 3rd will be 5 to the 6 plus 3, or 5 to the 9th. So what I basically am going to do is I'm going to leave the base of the power the same, and I'm going to add up the exponents. 4 plus 9 is 13, plus 1 is 14. Remember, if there isn't anything written here, it's assumed that it's the first power. Okay, sometimes we take powers to powers, right? So when you think about this item, 3 to the 4th squared, I've got this rule that says when I take a power to a power, I multiply the exponents. Okay, so when I have a to the m taken to the n power, it's a to the m minus n. And you know, if you think about that, that makes sense, because really when you think about like this problem, 3 to the 4th squared, that's the same as saying 3 to the 4th times 3 to the 4th. And we know from the previous rule that we would add the exponents. This would be 3 to the 8th. That's how we get 3 to the 4 happens 2 times, so it's the 4 times 2 to the 8th power. And remember, the base didn't change. Right? So the base of my power here is negative 5, and 3 times 4 is 12. Now we're looking at a different scenario. We're looking at a scenario where we have a single exponent, right? The exponent is the same, but we're multiplying with different bases. We can actually multiply the bases, or if I can factor the base of the power, I can split it into 2 powers. Okay, so it depends on what it is exactly we're trying to accomplish and which we would do. Sometimes you'll turn this into that, and sometimes that into this. So if I have 132 times 9 to the 6th power, that's 132 to the 6th power times 9 to the 6th power. Okay? But I could equally make that one single base. That would be the other way I might simplify this, would be 9 times 132. I could also say that this is 1188 to the 6th power. Okay, if we look at using all of the properties, I see here I've got negative 8 times m to the 4th, and that whole quantity is being squared. So that's going to become negative 8 squared. And then I'll have m to the 4th squared, which would be m to the 8th, times n to the 3rd, m to the 3rd. Negative 8 squared is 64. And I have m to the 8th times m to the 3rd. That's going to be m to the 11th power. An order of magnitude is the quantity that can be defined as the power of 10 nearest the quantity. So The key is power of 10. Okay, the power of 10 nearest to a quantity. If there are 91,000 species of insects, that's just about 100,000, which would be 10 to the 5th. Okay, so we would round to a power of 10 and then simplify it as 10 to a certain power. So if we take a look at our bees here, the U.S. Department of Agriculture collected data on 10 to the 3rd power bee colonies. And there are 10 to the 4th power bees in the average colony during honey production season. So how many bees were in the study? So there were 10.3 colonies, and each colony has 10 to the 3rd colonies and 10 to the 4th bees in each colony. So that means 10 to the 7th power is how many bees were in the study. Okay, that's the properties of exponents that involve products.